In this video, we're going to talk about factoring quadratics. And this video will probably be a little bit longer, so just be ready for that. All right, so before you start this video, just make sure you're comfortable with factoring using the greatest common factor. All right, so the first thing before we talk about factoring quadratics is we have to talk about what is a quadratic. All right, a quadratic function is anything where it can be written in this form, and for now it's pretty much going to be written in that form every time. All right, but the important thing is you see this x squared. This is x squared. It's no longer linear, right? We talked about linear equations a lot before, but now we can talk about quadratic equations when we have that x squared. All right, so previously we factored using the GCF, all right, the greatest common factor, but the problem with quadratics, if you look at this quadratic here, there's no greatest common factor. 2, 5, and 3 are not divisible by the same number. And there's x squared, x, and no x, so there's no x's in common between all the terms either. So using the greatest common factor is great at making things smaller, but it necessarily doesn't get you all the way to the fully factored form for an expression. All right, but what we're going to end up doing, or trying to do, is we're going to try to reverse the FOIL process. So we talked about FOIL before. If we wanted to multiply these two expressions, we do first, outer, inner, last, and it would turn into this expression. All right, so that was basically the distributive property to combine these expressions into a single one. But for a lot of instances, we want to go backwards. We want to turn this expression into that. So one thing that confuses students a lot is that this one expression with 3 terms is turning into 2 expression with 2 terms. If you just think about FOIL, it's just a reversing a process that we've already seen before. All right, so here's the steps. The method I'm going to teach you is called the splitting method. All right, there's so many ways that teachers teach factoring and that students learn factoring. So if you've already learned this and you have a way that you're comfortable, just do that method, because it's better to kind of just do the thing you're comfortable with and be good at it and do it over and over again rather than trying to learn a new method. But if you're learning it for the first time, this method is really useful for kind of practicing other parts of algebra, and it kind of is useful for a little bit longer than some of the other methods that are taught. So that's why I'm gonna teach it this way, called the splitting method. I'm gonna go through the steps, and as always, when I go through the steps in words, it never makes sense until we see an example. But I'll go through the steps first, and we'll kind of see why it's called the splitting method. All right. So when you're factoring a quadratic, the first step is you're kind of finding this perfect pair of numbers. So some like textbooks call it the perfect pair, something like that. All right, these numbers are gonna add up to b. All right, if you see, b is the middle number next to x. And that pair of numbers also at the same time needs to multiply to a times c. So a is the number in front of x squared, c is the number by itself. All right, so that's my first step. And this was the one that's most time consuming. So it's going through all the possibilities and finding this perfect pair of numbers. All right, after you have your perfect pair, you're going to split up, and that's why it's called the splitting method, split this bx up into 2 parts using the numbers. So let's just say I have bx, and my perfect pair of numbers was 2 and 3. Instead of writing bx, I'm going to write 2x plus 3x, because 2 and 3 were my perfect pair. All right, so that's why it's called the splitting method, and we'll see this in an example in a bit. All right, then what we're going to do is by splitting this up, so if I just use what I just had, all right, you can see I actually made the problem more complicated. I went from these 3 terms to these 4 terms. But the nice thing with 4 terms is it's an even number. I can split it up into 2 groups of 2. Okay. So that's the reason we make 4 terms, so we can split it up. And then unfoil to get your final answer. I feel like I'm missing a step. There should be like a step in the middle here of factor out the GCF. But we'll see it in practice in a second. All right, so 2x squared minus 5x minus 3. All right, this is the example. The answer was on your slide. Let's see how it's done. So first of all, identify A, B, include the negative. So B is -5, and C. So we need to find 2 numbers that add together to give B. And we need to multiply together to give A times C, which is -6. Now, in general, it's always kind of, there's less options for to multiply than to add, right? There's an infinite number of ways to add to -5. So I always start with the multiplication. To multiply to give -6, there's 6 times 1 and 3 times 2. And since it's negative, one of them has to be negative. I'm not going to put a negative sign there because that's just kind of like a reasoning thing we'll have to do. All right, so 6 and 1 and 3 times 2 are the only ways to multiply to give 6. But we wanted to multiply to give -6, and add to -5. So think about all the combinations of where you can put a negative, and the answer ends up being -6 and +1. All right, let's just double check that works. -6 plus 1 is -5. That's right. -6 times 1 is -6. The most common error I could see a student making for this one is saying -3 and -2, because those add to -5, but they multiply to +6, not -6. So just double check your perfect pair, make sure it works. But our perfect pair is -6 and 1. So after I find my perfect pair, we're doing the splitting method. So I'm going to split the middle of my expression. Instead of writing -5x, I'm going to use my -6x. I'm going to use my +1x. All right, so this looks really weird because I made the problem seem more complicated. I split this term up into these two separate terms. All right, but just notice that these terms, these numbers, are coming from my perfect pair that I found. And now, again, the reason I make it more complicated is because I can separate these into two groups of 2. This first group of 2, this is kind of that step I accidentally skipped in that slide, is to factor out the GCF in each of these pairs. All right, so in this first pair, the GCF is 2x, and that leaves behind x minus 3. The second pair, the GCF is just 1, and that leaves behind x minus 3. And now I know that part of my answer, my final answer, is going to be this x minus 3 that I see twice. All right, so that's one set of parentheses. The other set of parentheses is the other stuff, the 2x plus 1. All right, so the factored form of this is x minus 3 times 2x plus 1. And you could check yourself by foiling and make sure if you foil, you get back to where you started, because factoring is just undoing FOIL. All right, so we're gonna do a few more examples. I'm gonna try to go a little bit quicker, all right, just for time in the video. All right, but here we want to add to -5, we want to multiply to -24. All right, the ways to multiply are 24, 24 and 1, 2 and 12, 3 and 8, 4 and 6, 5 doesn't work. All right, so those are the ways to multiply, and I want to add to -5. So my perfect pair is going to be -8 and +3. Okay, and again, this is the process that's going to take the longest when you're starting out doing this. All right, but 12x squared, we're doing the splitting method, -8x plus 3x minus 2. And it doesn't matter which order I write these. I could do plus 3x minus 8x. Your steps would just be a little bit different, but you'd still get the same answer. I have my two groups of 2. First group of 2, 4x is the greatest common factor. Second group of 2, it's 1. So my final answer, 3x minus 2 times 4x plus 1. All right, real quick to do after you find that perfect pair. It's kind of those last couple steps, but if you're comfortable finding the GCF, you're comfortable working with multiplication, you can do this process. All right, so here's another example. I want to add to give b -4. I want to multiply to give a times c. What is a in this case? It's the number in front of x squared. If there's nothing there, that means it's a 1. And so in this case, 1 times -12 is -12. All right, so what numbers multiply to give -12 and add to give -4? This would be a great time to pause the video and try to find it yourself. All right, but it's going to be -6 and +2. All right, so we're going to have x squared. Let's just write it in the opposite order the way I've done it. So let's put the plus 2x first, then minus 6x minus 12, just to show it doesn't matter which one I write first, the bigger number or the smaller number. All right, my first group of 2, the only thing in common is an x. And if your second group of 2, if it starts with a negative sign, you almost always want to factor that negative sign out, because then it's going to match your first set of parentheses. In this case, I'm going to factor out -6. That's going to add x plus 2. My final answer, x plus 2 is half the answer, and what's left over, x minus 6. All right, so here's one for you to try on your own. At 6x squared plus 5x minus 4. It might take a little bit of time, just make sure you're doing the steps correctly. All right, find that perfect pair, do the splitting method, and get your final answer. All right, so go ahead and try that one. I'll show you the answer in 3, 2, 1. And this is the final answer. All right, my perfect pair was 8 and -3. I decided to write it in this order. If you wrote it in the other order, you probably got these final answers kind of flipped. Doesn't matter if they're flipped, this is also the same answer. All right, but as long as you're finding that perfect pair, doing the splitting method, and getting to your kind of unfoiled version, then you're doing great. All right, so I'm going to do a couple more examples at the end of this video. I know this video is already pretty long, so if you want to stop here, if you're already kind of confident, but if you want to see a couple more examples, I'm going to do those now. All right, but don't feel the need to watch the full video if you're already comfortable. Go in, practice. All right, so here's another example, 6x squared plus x minus 35. We want to add, again, if there's no number in front of that thing, I don't see a number in front of the x, it just means a 1. So I'm going to add to give 1 and multiply to give, I'm going to use calculator because 6 times 35, 70, 140, 210 is my guess. It is 210. Okay. All right, so I want to, negative 210 because it's negative 35. All right, so I want to multiply to negative 210 and add to give 1. So here's how you can figure out all the ways you can multiply to give a number. You start at 1. You can always do 1 times the number. After 1 is 2, so I'm going to, in my calculator, I'm going to type 210 divided by 2, and I see that's 2 and 105. Next, I'm going to do 210 divided by 3. That's 3 and 70. Next, I'm going to do 210 divided by 4. When I do 210 divided by 4, I get a decimal, so that means it's not an even thing, so I can skip 4. Next is 5 and 42. 6 works, 6 and 35. 7's going to work, 7 and 30. This one has a lot of factors. 8 does not work. 9 does not work. 10's going to work, 10 and 21. 11 doesn't. 12 doesn't. 13 doesn't. 14 and 15. And once this right-hand column, once I've tried all the numbers and I've gotten to a number that's in the left-hand column, I can stop. Because now if I started at 15, I would just get 14 and kind of be going back through the numbers. So you don't have to go all the way up to 210 to try. All right, but that's how you can do it. Just start at 1 and basically keep going until you get to a number that's in the left-hand side. So by going down 1 up to 14, the next number would be 15, but that's already on the left-hand side, so I know I'm done. And the perfect pair, all right, these are the ways to multiply to give 210. I need to add to give positive 1, so my perfect pair is going to be 15 and negative 14. And it doesn't matter what order you write them. I'm going to put the 15 first for literally no reason. It's because the one I wrote first on the bottom. All right, my first pair, I can factor out a 3x. That's going to be behind a 2x plus 5. My second pair, again, if you ever see a negative in front of this third term, you're going to factor out a negative. So in this case, I'm going to factor out negative 7, which is going to turn this into positive 2x and positive 5. And you do that so these terms are the same. You can't do this if these two terms aren't the same. So this becomes 2x plus 5 times 3x minus 7. All right, so that's just another example and kind of going through in detail how to find the factor of a big number. All right, for example in this video, and then I'll force you to practice. All right, but this is going to be adding to 38 and multiplying 5 times 16. Again, I'm just using a calculator just because the numbers are getting a little big. 80. All right, negative 80 again, because 5 times negative 16. The ways to multiply to give 80, 1 and 80, 2 and 40. 3 is not going to work. 4 and 20. 5 and 16. 6 doesn't work. 7 doesn't work. 8's going to work. 8 and 10. Then I would try 9. 9 doesn't work. And my next one I would try 10, and that's already on the left-hand column. So I know I'm done. All right, so these are the possible ways I can multiply to give negative 80. And I want them to add to positive 38. So my perfect pair is going to be positive 40 and negative 2. Again, that last step I do pretty quickly. All right, but figuring out which of those pairs, where do you put the negative to make it work? All right, it's a little bit of trial and error, but just make sure you double check those add to positive 38 and they multiply to negative 80. All right, so I'm good. Let's put the minus 2 first for no reason. Again, it doesn't matter which order you put your perfect pair numbers as long as they both split there. This first pair, I can factor out an x. Second pair, I can factor out, let's see, 40 and 16 are both those by 8. So I can factor out an 8. Again, I'm trying to factor out the greatest common factor, so the biggest number that divides 40 and 16 is going to be 5x minus 2. And now I unfoil 5x minus 2 times x plus 8. All right, so just another example of the same thing. All right, this algorithm is the same every time. So you just do that. All right, again, this step here is probably the one that's going to take the longest when you're first doing this. But those next 3 steps are always the same. So it's nice that it's just the same process over and over. You're just getting used to the steps. All right, so now go and practice. If you need extra help, let me know. All right, that should be enough to kind of get you going and working on factoring quadratics.